Alright, so let's start with the first question. An annuity provides a payment of N at the end of each year for N years. The annual effective interest rate is 1 over N. What is the present value of the annuity? Okay, so this question is quite straightforward because all you need to do is just form the equation of A over N with the given interest and given time. So therefore here, the question says that the annuity is for N years and the interest given is I equal to 1 over N. So therefore all you need to do is just substitute the values given in here, so it will become like this. So we just need to rearrange this whole expression so that it becomes the simplest form. So like this. And lastly, we will get here, which is the final answer. Proceed to the next question. Find a double dot angle 8 if the effective rate of discount is 10%. So this question is also straightforward because all we need to do is to insert the values here, which is given D equals to 10%. So here is the formula for a double dot angle. 1 minus V to the power of 8 actually here, and we substitute with 8, and D we insert with 0.1. So here is the calculation, and therefore here is the answer, which is 5.6953. Find the present value of payments of $200 every 6 months, starting immediately and continuing through 4 years from the present, and another $100 every 6 months thereafter through 10 years from the present, if I2 equal to 0.06. Okay. So here we will construct the timeline diagram first to represent the equation, to represent the question. So if you look carefully, the question explains that there are actually two series of payments of $100 each, which one is from year 0 to year 4, which is in the first statement, and another one which is from year 0 to year 10. So that's why the question said that $200 is present at the first 4 years, because it is actually the sum of two series of payments of $100 each. Therefore, to solve this question easier, we need to determine the number of payments for each of the series. So as you can see here, from year 0 to year 4, there were 9 payments of $100, and from year 0 to year 10, there were 21 payments were made during the series of payments. During the annuity. So to calculate the present value, we can easily sum up the total annuities of the two series of the payments, which is, the formula will be formed like this: 100 times with a double dot angle 21 plus with a double dot angle 9. So therefore, here is the calculation. So since we are using double dot angle, so the formula is going to be 1 minus Vn over D. So D we need to calculate separately, which is this: D equals to 3 over 103. So therefore, when we calculate the equation here, so we will get the answer, which is $2,389.72. A worker age 40 wishes to accumulate a fund of retirement by depositing $3,000 at the beginning of each year for 25 years. Starting at the age 65, the worker plans to make 15 annual withdrawals at the beginning of each year. Assuming that all the payments are certain to be made, find the amount of each withdrawal starting at the age 65 to the nearest dollar. If the effective rate of interest is 8% during the first 25 years, but only 7% thereafter. So in this case, the question indicates that there are two series of payments, which is we assume that the payments start from 1 to 25, and then the withdrawal will start continuing from this 25, which is 1 here, to 15. And given the different interest rate, which is 0.08 and 0.07 respectively. So firstly, we need to calculate the amount of fund that has been accumulated. So since the question said that the worker deposits at the beginning of each year, so therefore we will use the formula of 3000 times with S double dot angle 25, which therefore, using the calculation so on, we will get $236,863.25. And then the value we get here is actually the present value for the withdrawal here. Sorry, the withdrawal series here. So our equation is going to be R, which is the amount of each withdrawal times with A double dot angle 15, which is equal to 236,863.25. So solving the equation here, thus finally we will get the final answer, $24,304.92. But since the question asks for the nearest dollar, so here is our final answer, $24,305. Right. Find the present value to the nearest dollar on January 1 of an annuity which pays $2,000 every 6 months for 5 years. The first payment is due on the next April 1, and the rate of interest is 9% convertible semi-annually. So the question asks for the present value, so we need to create a timeline diagram which will ease our calculation later on. So here is the diagram. So if you look, so payments from 4th April year of Z to the 4th April of Z plus 5 is 2000 A angle 10, which is from here to here. The payment is gonna be, there are 10 payments here, since the question said that the payment is convertible annually, semi-annually. So therefore 5 years is times with 2 equals to 10 payments altogether. So that's why the equation is going to be this. So but since the question asks for the present value from here, so therefore there will be an additional interest which is starts from here. So carrying this value from this to this, which we will make the date of 4th April as our focal point, we will obtain here V 0.5. This is because that from January to April, in terms of convertible semi-annually, is actually 3 months, which equals to 4 years here, 1/4 years. So we multiply with the convertible rate, which is 2 semi-annually, thus we will get 1/2 here. So therefore our expression for the additional interest that we need to calculate is going to be V to the power of 1/2, or 0.5. So therefore our present value is going to be, our total present value is going to be 2000 A angle 10 times with V to the power of 0.5. So lastly we will get $16,177.59. Before that, we need to find the real value of interest, since the question only gives the convertible semi-annually rate of interest. So therefore we will divide rate here, which is 0.09 by 2, which we will get the real interest, which is 0.045. Deposits of $1,000 are placed into a fund at the beginning of each year for the next 20 years. After 30 years, annual payments commence and continue forever, with the first payment at the end of the 30th year. Find an expression for the amount of each payment. Okay, the expression for the amount of each payment, it actually refers to the payment from the 30th year and onwards, which is we don't know yet. So therefore, since both of the annuities share the same present value here, so therefore our equation is going to be 1000 times with A double dot angle 20 equals to R, which is the payment, which is the annual payment, times with V30 times with A double dot infinity, angle infinity, sorry. V30 is actually formed from here. Since the investment is continued from the time 0, which is in front here, so there will be existing an interest rate here, which is V30. So therefore our equation is going to be like this: 1000 times with 1 minus to V to the power of 20 over D, since we are using the double dot angle formula, equals to R times with V30 times with 1 over D, which is the formula for the A double dot angle infinity, because this is the concept of perpetuities here. So here is the formula for this. So therefore all we need to do is just factorizing this equation into the simplest form. So finally we will get the following expression, which is 1000 times with 1 plus I to the power of 30 minus 1 plus I to the power of 10. So let's continue. A level perpetuity immediate is to be shared by A, B, C, and D. A receives the first N payments, B the second N payments, C the third N payments, and D all the payments thereafter. It is known that the ratio of the present value for C's share to A's share is 0.49. Find the ratio of the present value for B's share to D's share. So the timeline diagram is going to be like this. So we need to, for each of the person here, which is A, B, C, and D, we need to form an expression which represents their respective present values. So therefore, since A is the starter, so the expression for present value for A is A angle N, and B becomes V to the power of N times with A angle N. This is because that during the investment period, the present value here is collected throughout the annuity, which is here. So this also applies to the other beneficiary, which is C and D. So that's why there exists an interest rate here. So therefore this will be carried forward also, and this will be carried forward also. So V to the power of 2n here, and here is also V to the power of 3n. So therefore the expression for B is V to the power of A angle N. C will become V to the power of 2n times with A angle N, and D V to the power of 3n times with A angle N. So we need to find the exact ratio, the expression ratio for C to A, which is here. So therefore we will get the value of V to the power of 2n, which is equal to 0.49. So we need to save this for information later on, because this is going to be useful. So we need to represent the ratios for B and D, which is here, V to the power of n A angle N over V to the power of 3n A angle infinity. So therefore when we simplify the expression here, we will actually get the equation is like going to be like this. So therefore lastly we will get this equation, So we can substitute all the values here. Oh, before that, Vn is actually obtained from the value of V to the power of 2n, because we can express the value is like this: V to the power of n square equals to 0.49. So square root both sides, we will get Vn to the power of 0.7. So therefore, our last calculation is going to be 1 minus 0.7 over 0.49. Therefore, we will obtain the answer, the ratio, which is 30 over 49. Compute A angle 5.25 if I equals to 5% using the following definitions. A, using the formula section 3.2. B, a payment of 0.25 at time 5.25. And C, a payment of 0.25 at time 6. So firstly, for A, the formula 3.2 is actually refers to this formula, which is denote that A angle n plus k is actually equals to A angle n plus V to the power of n plus k times with 1 plus I to the power of k minus 1 over I. So here, n is actually the full payment or the full period of the year, and k is actually the final fraction of the extra period. So therefore, in this case, since the question asks for A angle 5.25, here we can see that the full year is actually 5, which is 5 years, and k is actually 0.25, which is the final fractional period of the payment. So therefore, substitute those values here, we will get lastly 4.51945. For question B, a payment of 0.25 at time 5.25. So the payment here is actually refers to the extra payment that need to be made. So therefore, the equation is going to be A angle 5 plus 0.25 times with V to the power of 5.25. So calculate those values, we will get the answer, which is 4.5230. For C later on, A angle 5.25, which equals to A angle 5 plus 0.25 times V to the power of 6. Since we just need to adjust the value of time from question B here, so the calculation is going to be same, but only with the different values, which we will get the answer 4.5160. So let's proceed to the next question. A fund earning 8% effective is being accumulated with payments of $500 at the beginning of each year for 20 years. Find the maximum number of withdrawals of $1,000 that can be made at the ends of years under the condition that once withdrawals start, they must continue through the end of the 20-year period. So we need to create the timeline diagram for the question above. So here is the timeline. From year 0 to year 20, the fund will accumulate from a series of payments of $500 for each period to year of 20. So we need to find how much the fund accumulates to year 20. So our formula is going to be X. Denote that the accumulated value is here. So our equation is going to be X equals to 500 times with S double dot angle 20 equals to 500 times with 1 plus I to the power of 20 minus 1 over D. So since we are using D here, so we need to find the value of D first, which is equals to I over 1 plus I. Given that I is equal to 8% here, so therefore our D is going to be 2 over 27. So finding the X, we will get $24,711.46 for X. So actually, based on the timeline here, the value that is accumulated here will be used for the withdrawals. So we need to find the numbers of payments that can be made using this accumulated fund, which is the $24,711.46. So the formula is going to be, since we are using in terms of accumulation here, so we are going to use the formula of 1000, which is the series of payment made after the year of 20, times with S angle N. So based on, so substitute the values here and here, so we will get the last expression, which is N equals to ln 2.9769168 over ln 1.08. So approximately our N will become 40.1745, which approximately the total withdrawals that can be made is 14 years. Next, a borrower has the following two options for repaying a loan. 1. 60 monthly payments of $400 at the end of each month, or option 2, a single payment of $6,000 at the end of K months. Interest is at the nominal annual rate of 12% convertible monthly. The two options have the same present value. Find K with two methods, which is A, an exact basis, and B, method of equated time. Alright, so first things first, before we solve both of these two questions, so we need to calculate the real interest rate here. Since the interest rate is convertible monthly, so therefore 0.12 will be divided by 12, so we will get the real interest rate with this J is equal to 0.01. Alright, so for A, for exact basis is actually the normal equation that we can represent the question itself. So since the question said that both of the methods have the same present value, so we can express the equation as follows. 100, here is for the method 1, which is payment of 100 times with A angle 60, because of the 60 of payment for each month, which is equals to 6,000 times V to the power of K. So therefore, here is our expression, 100 times with 1 minus V60 over 0.01 equals to 6,000 times with 1.01 to the power of negative K. So we will get the last expression of K, which is, take a look at the expression here first. So here, alright, and then we will get lastly the expression of K, which is ln 0.74925 over negative ln 1.01. Thus we will get K approximate to 29.0124, which is actually equals to K equals to 29. So that's for the first question. For the second question, for the equated time method, so we denote that equated time is actually T bar, which is equal to K. So T bar, which is the equated time, is actually the sum of payments times with the time of payments over total payment. So since there are 60 payments here, so our total here will become 100 times 1 plus 100 times 2 until the sum of 100 times 60 over the total payment, which is the exact 60 payments times with 100. Therefore we will get, here is going to be 6,000. And to simplify this, we just have to calculate the summation of 1 plus 2 plus 3 plus 4 until 60 here. So therefore this will actually become 1,833. So 1,830 times with 100 over 6,000 will get 183,000 over 6,000, which is equals to 30.5. A beneficiary receives a $10,000 life insurance benefit. If the beneficiary uses the proceeds to buy a 10-year annuity immediate, the annual payout will be $1,538. If a 20-year annuity immediate is purchased, the annual payout will be $1,072. Both calculations are based on the annual effective interest rate of I. Find I. So here is our timeline diagram, which represents for the first annuity method, which is from 0 to year of 10 here. So since both have the same present value, so we can create an equation which is 1538 times with A angle 10 equals to 1072 A angle 20, which is also equals to 1538 times with 1 minus V to the power of 10 over I equals to 1072 times with 1 minus V to the power of 20 over I. So we will expand the equation here, which will become like this: 1538 minus 1538 V to the power of 10 over I equals to 1072 minus 1072 V to the power of 20 over I. So both I can be cancelled out. So therefore we'll be left with this expression. So if you notice, this can be created into a quadratic equation. So rearrange this expression, we will get 1072 V20 minus 1538 V10 plus 466 equal to 0. So we let V10 equal to X, so we will get this expression here. So using the formula, we will obtain X equals to 0.4347 or 1. We will reject the value of 1 because when we substitute into equation X, we will get the interest rate is equal to 0, which is exactly not the logical answer. So we know that we let V10 equal to X, so V10 equals to 0.4347. So substitute V with the value in terms of 1 plus I, which is also equals to 1 plus I to the power of negative 10. So the expression will become like this. Rearrange the equation. Thus, we will get I equals to 0.08688, or to be precise, 8.969%. Find the present value of an annuity immediate for 5 years. Denote by A angle 5 if I equals to 0.06 plus 0.002 times with T minus 1 for T equals to 1, 2, 3, 4, and 5 respectively, where T is the interpreted according to A, yield curve method, and B, portfolio method. So before solving this equation, find the value of I with the respective value of T, 1, 2, 3, 4, 5. So we are going to obtain the series of interest rate, which is 0.06, 0.062, 0.064, 0.066, and finally 0.068. So first, for yield curve method, the formula is going to be the summation of 1 plus I k to the power of negative k, or we can denote the equation as V. So since there are only 5 periods here, which is 1, 2, 3, 4, and 5. So therefore, the summation is going to be V plus V to the power of 2 plus V to the power of 3 plus V to the power of 4 plus V to the power of 5. So our expression is going to be 1 over 0.06 plus with 1 over 0.062, which is the second period here, and so on until the end, which is 1 over 0.068 to the power of 5 Therefore, we will obtain the total of A angle 5, which is 4.1543. Next, for portfolio formula is, like I underline here, it's actually the summation of product of 1 plus is to the power of negative 1. To make it easier for you, so this is going to be the expression 1 over 0.06 plus 1 over 0.06 times with 0.062, and then the pattern is going to be proceeding like this: 0.062 times with 0.062 times 0.064 until the last term, which is here, 0.06 times with 0.062, and so on and so forth until we obtain this. So therefore, calculate the total of these 5 terms here. We will obtain 4.1831. At an annual effective interest rate of I, both of the following annuities have a present value of X. 1. A 20-year annuity immediate with annual payments of $55. Only 55. And 2. A 30-year annuity immediate with annual payments that pay 30 per year for the first 10 years, 60 per year for the second 10 years, and 90 per year for the final 10 years. Calculate X, which is the present value. So, since the question said that both of these two methods have the same, both of these two annuities have the same present value, so we can express our equation as follows: 55 times with A angle 20 equals to 30 A angle 10 plus 60 A angle 10 times with V10 plus 90 times with A angle 10 times with V to the power of 20. So the reason for the existence of V here is because that during the series of payment, the interest rate is also included during the annuity payment. So therefore, when we carry forward here, so we will set here as our focal point. So from the payments of $60 to the payment of $30, there will be existing of V10. So for 90 also, there will be existence of V20 here for each of the annuity series. So therefore, when we calculate, so substitute all the equation here, so we will get 55 times with 1 minus V to the power of 20 over I equals to 30 times with 1 minus V to the power of 10 over I plus 61 minus V10 to the power of I times with V20 plus 90 1 minus V to the power of 10 over I times with V20. Thus, we will cancel out all the i's. So factorizing the expression, simplify the expression, we will get negative 90 V power of 30 plus 85 V to the power of 20 plus 30 V to the power of 10 minus 25 equals to 0. So we will going to assume that V10 is actually equal to X. So we are going to solve this using cubic equation. Negative 90x cubed plus 85x to the power of 2 plus 30x minus 25 equal to 0. So by factorization, we will obtain x equals to 1, negative 0.55 and 0.5. So we will reject the value of 1 and negative 0.55 as follows, because when x becomes 1, our interest is going to become 0 later on. And also the negative values here, 0.55, our interest is also going to be negative value, which is unlogical answer. So we will take the value of x is 0.5. Yep. So let 0.5 equals to V10 earlier on. So we will obtain 0.5 equals to 1 over 1 plus I to the power of 10. And then we rearrange the expression here. We will obtain 1 plus I to the power of 10 equals to 2. 2 is the resulting from 1 over 0.5, which is from the expression here. So we will rearrange all of the terms here. We will obtain I equals to 0.07177. But since the question asks for the present value of the both of the annuities, so we will using the first annuity, which is 55A angle 20, for easy calculation. So therefore, substitute our value, substitute the formula of A angle 20 with the formula of 1 minus V20 over the interest rate that we obtain from here. So we will get, so calculate this, substitute all of the values given. So therefore we will get lastly $574.60.
Time wizard!